completion of this exercise, the trainee shall be able to dismantle the alternator and clean the parts, examine the starter and rotor for open circuit and closed circuit, evaluate the slip rings, assemble the alternator.
Tools and equipments required: trainee's toolkit, digital multimeter, continuity meter, ohm meter, DE spanner 6 to 32, electrical tester, vehicle, AC alternators slip ring puller, executive auto electrical toolkit, electrical test bench, pulley set universal for bearing and bushes. Materials required: carbon brush as required, diode as required, kerosene as required, bunion cloths as required, brushes as required, petrol as required. Let us start the session by understanding the operation of an alternator. When starting the engine, a critical process is set in motion within the alternator. The engine's belt drives the motor assembly, which contains S and N poles of a rotor magnet. As the rotor assembly rotates, these poles passes through each stator coil. This rotation induces an alternating current AC in the starter coil, oscillating between positive and negative. The generated AC is then directly through silicon diodes mounted on a heat sink, facilitating the conversion of the alternating current to the direct current DC. The heat produced during this conversion process is dissipated by the heat sink. The converted DC current travels through the battery terminal, the ammeter, and finally charges the battery. This process ensures a consistent and efficient supply of electrical energy to power the vehicle's electrical system while maintaining the battery's charge. Let us start with dismantling the alternator. For the purpose of facilitating alignment easier during the process of reassembling, mark a line that runs across both the end shields and the starter. Take off the studs and nuts that are used to secure the cover and then lift the lid. The regulator leads should be disconnected. It is necessary to unscrew the screw that is attaching the regulator to the brush box in order to remove the regulator. Take off the screw that is holding the regulator to the brush box and subsequently take out the regulator device. Extract both brushes and make a note of the sealing pad's position. Proceed by undoing the screws that secure the brush box to the slip ring end brackets, then elevate the brush box. Release the starter winding cable ends from the rectifier by applying a hot soldering iron on the terminal tacks. Gently pull out the cable end when the solder melts. Remove the screws that hold the rectifier assembly to the end plate with the slip ring, and then lift the assembly. Take out the fixing bolts. Remove the end plate of the slip ring off. Remove the starter unit from the bracket at the end of the drive. Disassemble by removing the shaft nut, washers, and extracting the pulley, fan, woodruff key, and spacers. Use your thumb to push on the end of the rotor shaft to remove the drive end bearing from the rotor set. You can use kerosene and a nylon brush to clean all the parts except the brushes. Use fine emery paper and a clean rag to clean the slip rings. You can use petrol to clean the brushes. Look at the bearings to see if they are broken. If you need to, you can change the bearing with a new one. Check the brushes to make sure they are the right size according to the manufacturer's instruction and replace them if they need to be. Check if there are any cracks in the drive end bracket and the slip ring end bracket. Let us discuss the inspection of rotor for ground. To check the satisfactory rotor winding insulation, connect a 110 volt AC main with 110 volt 15 watt test lamp in circuit between either of the slip rings and the rotor body. The lamp should not glow. If it does, it indicates defective rotor winding and the rotor assembly needs renewal. To test an open circuit in rotor winding, connect a 12 volt bar 24 volt battery and a moving coil ammeter between the slip rings. The current should be 2 to 2.5 amp approximately for 12 volt. If not, renew the rotor. Use an ohm meter to measure the resistance of the rotor winding. The resistance should be 9.62 plus or minus 10 ohms for 24 volts alternator and 3.22 plus or minus 0.5 ohms for a 12 volt alternator. If the readings are not within the specified limits, renew the rotor assembly. Checking for any unintended electrical connection between the rotor winding and the rotor body or ground. Check for any open circuit in the rotor. Measure resistance between slip rings continuity less than 5 ohms. Indicates a healthy rotor. If there is no continuity, replace the rotor. Now let's check for grounded circuits. The ground continuity of the resistance should be infinite. If it is not infinite, you should replace the rotor. Here, in case of starter, you should check the continuity by connecting winding leads to a 12 volt battery. The lamp should glow, which indicates the continuity. Check the starter to see if it is broken or acting strangely. If so, replace the starter part. Let's discuss the slip ring surface. Check the slip rings for their trueness in a lathe. Use a dial test indicator to ensure the slip rings are within specified tolerances for roundness and concentricity. Inspect the surface of the slip ring for any signs of burning or dirt. Replace the slip rings if required. Now let's discuss the testing and assembling of the alternator. As informed while dismantling, ensure that the scribed reference lines are in alignment during assembling. Assemble the rotor assembly with the drive end bearing to the drive end bracket and secure the bearing retainers with screws. Assemble the spacer, woodruff key, fan and pulley on the rotor shaft. Assemble the starter assembly to the drive end bracket. Place the rectifier assembly to the slip ring end bracket and secure it with screws. Place the slip ring's end bracket and fix the fixed bolt stud. Solder the starter winding cable ends to the rectifiers. Place the brush box on the slip ring end brackets and secure it with screws. Place the sealing pad and position both brushes. Place the delivery brush mounting plate in position and secure it with screws. Place the regulator on the brush box and connect the regulator leads. Secure the regulator in place with screws. Place the cover and fix the cover securing studs and washer. Tighten the nuts firmly.
Let's recap this session. In this session, we learned that the regulator's leads should be disconnected. It is necessary to unscrew the screw that is attaching the regulator to the brush box in order to remove the regulator. To check the satisfactory rotary winding insulation, connect a 110 volt AC mains with 110 volt 15 watt test lamp in circuit between either of the slip rings and the rotor body. The lamp should not glow. If it does, it indicates defective rotor winding and the rotor assembly needs renewal. Use a dial test indicator to ensure the slip rings are within specified tolerance for roundness and concentricity. Hello and welcome to the session. In this session, we will take a look at performing troubleshooting, exploring possible causes, and finding remedies for various starter motor issues such as not running, running too slowly with low torque, running but not cranking the engine, unusual noises, and cases where the starting motor doesn't stop running. We will also cover growler testing for rotors. By the end of this exercise, you will be able to resolve issues when an engine refuses to crank, address situations where the engine cranks too slowly, tackle problems when the starter spins but the engine doesn't crank, rectify issues with the starter not engaging or disengaging properly.
Tools and materials required: trainee's toolkit, multimeter, cotton waste as required, magnetic switch as required, petroleum jelly, brush as required. Let us begin this topic by determining the underlying causes of this issue. One possible cause of the issue could be the fusible link. The fusible link is designed to break the circuit in case of any electrical issues, which helps to prevent damage or hazards. If you find that the fusible link has melted, then it needs to be replaced with a new one. Ensure all the electrical connections related to the starter motor and the associated components are clean and securely tightened. Loose or corroded connections can disrupt the flow of electricity. Check the condition of the battery. If it is dead or has a low charge, recharge it. A fully charged battery is crucial for proper starter motor function. Check if the ignition switch is working properly. It is responsible for sending a signal to start the engine. If it is not working right, replace it with a new one. The magnetic switch or solenoid is important for starting your car. If it is not working right, you should change it. The solenoid is the part that makes the starter motor turn when you use the key to start the car. Here are few issues related to a slow cranking engine. Check the battery voltage using a multimeter. If it is below the recommended level, recharge or replace the battery. Check the battery terminals and cable connections. Clean any corrosion and tighten loose connections. This ensures a good electrical connection. Investigate any mechanical issues that may be causing resistance in the engine. This could include problems with the piston, crankshaft, or other internal components. Identify and address any worn out parts in either the engine or starter system to ensure optimal performance. Test the starter motor. If it is not functioning correctly, it may need to be replaced. The next issue is that the starter keeps running. Inspect the ignition key for any signs of bending or damage. If identified, replace the key to ensure smooth operation. Inspect the control components linked to the starter system, such as switches and circuits, and replace any faulty parts causing continuous starter operation. Additionally, examine the pinion and ring gear for damage. If either component is compromised, replacement is essential to restore proper functionality. When the starter spins but fails to crank the engine, potential causes include a faulty overrunning clutch or damage to the pinion gear or ring gear. To address this issue, check the overrunning clutch for faults. If required, repair the clutch to ensure proper operation. Examine both the pinion gear and ring gear for any indications of damage or wear. If either component is compromised, replace it as necessary to restore the proper functionality of the starter system. When the starter fails to engage or disengage properly, potential causes include the following. Check the magnetic switch for faults. If identified, replace the switch to ensure proper engagement and disengagement of the starter. Inspect both the pinion gear and ring gear for damage or wear. If either component is compromised, replace it as needed to facilitate the proper operation of the starter system. The next issue could be starter motor noise. If the pinion shows sign of wear, replace it to eliminate the noise. If the bearings are worn out, replace them to ensure smooth and quiet starter operation. If the mounting is loose, tighten it securely to prevent unnecessary noise during starter operation. If the ring gear is worn out, replace it to eliminate noise and maintain proper engagement with the pinion. The next issue could be starter motor does not stop running. When the starter motor does not stop running, potential causes include a short-circuited starter switch, a struck starter relay contact, or a binding ignition switch. The next topic that we are going to discuss is growler test for routers. A growler is a electrical device commonly used in the field of motor testing and maintenance. Using a ohm meter, check continuity between the commutator and armature core. Infinite resistance signal sounds insulation. For open circuit assessment, test continuity between adjacent commutator segments. No needle deflection indicates a discontinuity, requiring armature replacement. Inspect commutator runout by placing the armature between V blocks. Correct runout with a lathe if necessary. Measure commutator diameter and recommend armature replacement if below specified limits. Clean the commutator surface with 400 emery cloth and adjust the mica depth if under 0.2 mm. These streamlined steps ensure thorough testing and maintenance, optimizing motor performance.
Let's recap this topic. In this topic, you have learned that troubleshooting involves addressing issues such as engine not cranking, slow cranking, or starter malfunctions. Diagnostic steps include checking for loose connections, a dead battery, faulty ignition switch, or issues with the magnetic switch. Additionally, a growler test can identify motor faults like earth faults, short circuits, and open circuits. Hope you have clear understanding of this. Do this exercise with help of your instructor. Thank you. Welcome to this session on checking a starting system, jumpstart a vehicle, and tracing the light circuit. By the end of this exercise, you will be able to check the starting system of the vehicle, identify the purpose of a jumper cable in starting a vehicle, identify the essential components of a vehicle's lighting system, understand the roles of switches, fuses, and wiring harness in the lighting system.
Tools and equipments required: trainee's toolkit, test lamp, multimeter. You will also need a running vehicle, soldering iron, pull-out tool. Materials required: cotton waste, emery sheet, battery, jumper cable, auto electrical wire, insulation tape, bulb, fuse, cleaning solvent. Let us start this session by understanding the starting system. The starting system begins when the starter switch is pressed or turned, allowing the current from the battery to reach the starter motor. This rotation of the motor's shaft connected to drive pinion turns the engine's flywheel until it starts running. Now, let us have a look at the procedure to check the starting system of the vehicle. Let's begin the procedure by placing the vehicle on a flat surface floor. Place wooden chokes in the front and the rear wheels to prevent it from rolling. Wooden chokes acts as a wedges, creating a barrier that helps secure the vehicle in place, especially when performing maintenance or inspections on a flat surface. This precaution ensures safety by reducing the risk of unintended rolling or movement while working on the vehicle. As a next step, proceed to examine the battery terminals for sulfur deposits, which is a common issue that can impede electrical connections. If you find any deposits are present, remove the terminals and meticulously clean them, along with the battery posts and cable connections, using hot water and an emery sheet. After cleaning, reconnect the battery terminals, ensuring a secure and tight fit. To assess the battery's condition, use a hydrometer to measure electrolytes' specific gravity and a voltmeter to check voltage levels. Then check the starter motor's battery cable connection and mounting points for any signs of wear or damage. Moving on to the ignition system. Turn the key to switch on the vehicle's ignition and activate the glow plug to warm up the combustion chamber. Subsequently, turn on the self-starter switch while carefully observing the interaction between the pinion and the engine flywheel ring gear. The speed and smoothness of the flywheel rotation provides valuable insights into the health of the starting system. A slow rotation may indicate a low battery charge. For troubleshooting purpose, have a fully charged spare battery on standby, connected to the vehicle's battery in parallel using jumper cables. Measure the voltage with a voltmeter to ensure an adequate power supply. Turn on the starter motor switch. Initiate the engine start and closely monitor the battery charging system's performance. Once the engine is running smoothly, indicating a successful start and proper charging, disconnect the jumper cable and spare battery. This detailed process ensures a thorough examination of the vehicle's battery, starting components, and related system, contributing to overall reliability and optimal performance. Always exercise caution and adhere to safety protocols while performing maintenance on vehicle electrical systems. Let's understand the types and uses of lighting system inside the vehicle. Let's get started. The lighting system of the vehicle brightens the visibility of the road for the driver and delivers illumination. There are different lamps that constitute the vehicle's lighting system for illumination, such as headlamp, emits light to the front of the car, fog lamp, extra front and rear lights designed to make it easier to see in foggy conditions, parking lamp are designed to make your car visible to other drivers when you are parked. Warning lamps are located in car dashboard that serves as a communication system between the car and the driver. Brake lamps lets you know that there is a fault in your braking system. Panel instrument lamps used to highlight the indications in dashboard. Tail lamp is used to signal the other drivers that you are slowing down or stopping, and the interior dome lamps illuminates when people enter or exit the car. The lighting system consists of different components such as switches, lamps, wiring, harness, and fuse. The different types of lighting circuits are headlight circuits, parking light circuits, panel light circuits, top light circuit, fog light circuit, stop light circuit, reverse light circuit. First is the headlight circuit. The circuit of headlights provides driver with enough light on the road to ensure proper vision. It is made up of a fuse, a headlight switch, a dim and dip switch, a reflector holder, a double filament, and a pre-focused bulb. Parking light circuit. There are two little lamps installed on the front and back of the car. When the car is parked on the road, it is used. It is sometimes controlled by a separate switch or the headlight switch. Panel light circuit. The driver uses tiny microscopic LEDs behind each panel board to see how the instruments are operating at night. A separate panel board switch connects these bulbs. A top or dome light circuit. The dome lamp is installed at the highest point of the car's roof. It is controlled by a different switch that is either in the door post or panel board. It gives the car interior lighting. Fog lamp circuit. The standard headlight beam is basically useless in mist or snow. The light is reflected backward by the mist. In these conditions, The fog light effectively brightens the area. It is made up of a switch, a reflector, and a yellow lamp. This signals traffic behind the car to slow down or halt when the stop or brake lights are used. The system includes a lamp and brake switch on the master cylinder or air valve. Pressing the brake pedal closes the switch, completing the circuit for the rear red light filament. The tail light. When traveling at night, cars are equipped with tail lights to offer visibility to cars behind. They light up the rear of the automobile so that at night approaching vehicles can see it. The reverse light. The beam of this reversing lamp is separated widely by its ribbed cover, which helps driver view the entire width of the road. Now we will learn about the alignment and aiming of headlights. First, let's start by setting and testing long and short beams. So start by adjusting the headlamp beams using vertical or horizontal screws on the back of the headlight. Ensure the main beam's high intensity zone falls as depicted. Adjust the higher beam independently after tossing it on the white screen. Point the headlamp main beam straight ahead and parallel to the road when the vehicle is fully loaded. Next, let's discuss the cause and remedies for the specific conditions. First, the headlight does not glow. Check if the bulb fuse is blown and replace it. For a loose wire connection, tighten it securely. If there is an open circuit in the wiring, inspect and repair the circuit. If the headlight bulb fuse is burnt out, replace it. If the headlight switch is defective, replace it with a new one. The other major kind of issue is that one headlight does not glow. The cause and remedies for these issues are: if there is a loose wire connection, tighten it securely. Replace the bulb if it has burnt out. Repair any open wire circuit. Replace the wire junction box if it is defective. Clean any rust formed in the earth wire connection. And the last troubleshooting is about the high or low beam does not work. If one filament in the headlight bulb is burned out, replace the bulb. Check and tighten the wire connection in the bulb holder if it is loose. If the diamond bright switch is defective, replace it. If the headlight is defective, replace the bulb holder.
Let's recap this topic. In this topic, you have learned that this process involves securing the vehicle, checking for battery sulfur deposit, cleaning if needed, and assessing battery, starter, and ignition system. Troubleshooting includes using a spare battery if required, ensuring a meticulous examination for reliability and optimal performance. The settings and testing of long and short beams, adjusting the headlamp beams using vertical or horizontal screws on the back of the headlight. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. Welcome to this session on performing troubleshooting in turn signal and hazard warning light. By the end of this exercise, you will be able to identify the troubles of the turn signal light. Examine the troubles in the hazard warning light circuit. Identify the troubles of the turn signal light. Examine the troubles of some light that does not light up.
Tools and equipments required. Trainee's toolkit, multimeter. You will also need a running vehicle, test lamp, materials required, cotton waste as required, soap oil as required, bulb as required, indicator light switch, hazard light switch, wire as required, insulation tape as required. We will discuss the steps to check and troubleshoot potential problems with the following: the battery connection, hazard switch wire connections, indicator turn switch wire connections, and various turn signal light issues. Now, let us have a look at the procedure to check the starting system of the vehicle. First, it's essential to inspect the battery connection for sulfur deposits. Sulfur deposits can hinder the battery's performance and lead to electrical issues. If deposits are present, cleaning the battery terminals with a suitable cleaner and ensuring a secure connection is important. Next, check the hazard switch wire connections and indicator turn switch wire connections. Loose or damaged connections can disrupt the electrical flow, affecting the proper functioning of the turn signals and hazard lights. Reconnecting or fixing the wires might be required. Now, start the engine and make sure that the battery is charging properly. Now, let us have a look at some of the common issues and solutions for vehicle signal lights and hazard warning lights. Some possible causes include a defective indicator switch, a faulty flasher unit, or a blown fuse. Replacing these defective components might be a solution for these issues. Another issue is a switch wire open circuit, which can be resolved by securing the connection, such as tightening the wire connection. If the turn signal lights do not flash, there could be two reasons. One is a defective flasher unit, which can be rectified by replacing it with a new one. The second reason may be loose wires, and this issue can be resolved by tightening the wire connections. For cases where only one side signal light is flashing, potential causes include a burned out bulb, disconnected wire connection, or a faulty indicator switch contact. Replacing the bulb, reconnecting the wire, or replacing the switch as needed will address this problem. Issues such as low turn signal light flash rates can result from various factors, including dirty breakpoints in the indicator switch, low power supply, use of low power bulbs, or poor ground connection. To address these issues, clean the breakpoints to resolve the dirty breakpoint problem. Check and correct the power supply for issues related to low power. Replace the low power bulb with the correct one and correct the grounding point to resolve the earth connection issues. Turn signal light flash rate high. This issue happens because of two reasons. The major reason might be because of the usage of high power bulbs. This can be rectified by using a correct power bulb. The other reason is because of the defective flasher unit. To resolve this issue, just replace the whole flasher unit. Lastly, hazards warning lights not flashing may result from a defective flasher unit, a faulty hazard warning switch, a burned out bulb, or incorrect wire connections. So, replacing these components will ensure the proper functioning of the hazard warning lights. In this discussion, we will explore the steps to troubleshoot when encountering the problem of all lights not turning on or some lights failing to light up. Check the clearance, the space between the tail light bulb and the number plate to ensure that there is no physical contact. Investigate why none of the lights are working. This should involve examining bulbs, wires, and the overall lighting system to identify and address any issues. Examine the wiring circuit responsible for controlling the height of the lights. Look for any defects or problems that might be affecting their proper functioning. Check the fuses within the lighting circuit. Make sure they are not blown or damaged, as this can often be a cause of lighting issues. Verify the power values of the bulbs. If the values are not within the correct range, replace any bulbs that are not working properly. Now, let us start with the possible causes and solutions when all lights on the vehicles are not glowing. A defective switch can disrupt the electrical circuit, preventing the lights from functioning. So, it is important to replace the defective switch with a new switch. Next, ensure there is a proper power supply reaching the lights. Check the power source and address any issues preventing power flow. Inspect all wire connections. If any are loose, tighten them securely to establish a reliable electrical connection. Ensure a solid earth connection to maintain consistent electrical flow. If you find any improper connection, then connect the wires properly. Fuses protect the circuit and can burn out due to electrical issues. Replacing the burned out fuse with a new one is the solution for this issue. An open circuit interrupts the flow of electricity and needs to be restored for the lights to work. Identify and connect the open wire circuit. Burned bulbs are a common cause of lights not glowing. So, replace all the burned out bulbs with new ones. Now, let us dive into possible causes and solution for low clearance between bulbs. The license plate may be improperly positioned, causing a low clearance between the bulb and the plate. The solution is adjusting the license plate to maintain the appropriate distance between the bulb and the license plate. Physical damage to the number plate can affect the space between the bulb and the plate. Solution: repair or replace the damaged number plate to ensure proper spacing. Now, let us dive into possible causes and solution for one side light or same lights not glowing. If a bulb is fused or burned out, it can result in one side or specific lights not glowing. To resolve this issue, replace the fused bulb with a new one of the appropriate type. Disconnection of the wire earthing can disrupt the electrical flow, causing lights not to glow. So, properly connect the wire earthing to restore the electrical continuity.
Let us recap this topic. In this topic, you have learned that for non-glowing turn signals, replace defective components and secure wire connections. Specific solution for one-side flashing, low or high flash rate issues include bulb replacement, wire reconnection, and addressing power supply or ground problems. To ensure proper functioning of vehicle lights, Start by checking the clearance between the tail light bulb and the number plate. Make sure there is adequate space. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. Welcome to this session on performing troubleshooting and remedies for fuel meter and fuel gauge units. By the end of this exercise, you will be able to identify and trace out the defects in the fuel meter and gauge circuit.
Tools and equipment required: trainee's toolkit, multimeter, a vehicle in running condition, cotton waste, soap oil, fuel gauge, wire and fuel tank unit as required. Now let us have a look at some of the common issues and solutions for the vehicle signal light and hazard warning light. A fuel gauge is an important component in a vehicle, responsible for providing real-time information about the level of fuel in the tank. It comprises a sensing or sending unit responsible for gauging the fuel quantity. The sending unit within the fuel tank is connected to the gauge, and through the signals transmitted by the sending unit, the gauge displays the current fuel level in the tank. There are different types of fuel gauges. They are microprocessor controlled gauges, thermostatic fuel gauges with self-regulation, and thermostatic fuel gauges with external regulation. When troubleshooting issues with the fuel gauge, several factors may contribute to inaccuracy or failures. Let's have a look at those. If the float inside the fuel tank is damaged, it can result in inaccurate readings. The float is a buoyant device that moves with the fuel level, and damage to it can compromise its ability to accurately measure the fuel level. In such cases, replacing the damaged float is necessary for precise readings. Checking the wires is another crucial step. If the wires connecting the fuel gauge to the sensor or other components are broken, it can disturb the flow of electrical signals and lead to faulty readings. Repairing or replacing the broken wires ensures a stable electrical connection and proper communication within the system. An empty fuel tank seems like an obvious issue, but it's important to mention it as a reminder. If the fuel tank is indeed empty, filling it up is the straightforward solution to address the low fuel level indicated by the gauge. The sensor sending unit in the fuel tank is crucial for precise measurements, and if it malfunctions, it can lead to inaccurate readings. In such cases, replace the damaged sending unit. Issues with resistance can also affect the accuracy of the fuel gauge. The resistance in the fuel gauge circuit needs to be within the specified range for precise readings. If there is an issue with the resistance, just replace it. The gauge itself might be the source of the problem. If the gauge is broken or malfunctioning, it cannot accurately display the fuel level. In such cases, replacing the entire gauge unit is necessary to restore proper functionality. Loose connections may result in sporadic gauge failures or unpredictable readings. So, it is essential to secure the wire connections in the gauge to maintain a dependable electrical link. If the float inside the tank is sticking, it can cause the gauge to get stuck at a certain fuel level. This issue can be resolved by replacing the sticking float with a properly functioning one. Checking and fixing any damaged ground wires in the tank is essential for maintaining proper electrical ground. A damaged ground can lead to electrical issues and impact the overall performance of the fuel gauge system. If the float is moving oddly or erratically, it can be indicative of a problem with the float mechanism. This issue may require either repairing the float mechanism or replacing it with a new one to ensure smooth and accurate movement. A deformed bimetal element or non-functioning heat wire can impact the performance of the thermostat fuel gauge. In such cases, replace the deformed element or the faulty heat wire is necessary to restore the proper functioning of the gauge.
Let us recap this topic. In this topic, you have learned that if the float inside the tank is damaged, it is essential to replace it to ensure accurate fuel level measurements. A broken gauge mandates replacement to restore accurate fuel level display. Tightening wire connection in the gauge is crucial for optimal performance. In the case of an empty tank, the immediate remedy is to fill it up. If the sensor in the tank fails, replacement becomes necessary for reliable fuel level reading. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. Welcome to this session on perform troubleshooting and remedy for engine coolant temperature ECT meter and ECT sensor. Engine coolant temperature meter shows no operation or incorrect operation. By the end of this exercise, you will be able to identify the cause for engine coolant temperature, replace the defective temperature and sensors, ECT.
Tools and equipments required: trainee's toolkit, multimeter, wire cutter, battery, vehicle with ECU, cotton waste, emery sheet, bulb, ECT scanner, thermostat, 3mm and 4mm wire, cleaning solvent, soap oil. Now let's have a look at the procedure or checking and maintaining the coolant system in a vehicle. This initial step is essential to ensure that there is an adequate amount of coolant in the radiator. Low coolant levels can lead to insufficient heat dissipation, increasing the risk of engine overheating. It's crucial to perform this check when the engine is cooled to avoid any potential burns. Monitoring the engine's working temperature is critical for assessing the efficiency of the thermostat valve. The thermostat regulates the flow of coolant through the engine based on temperature. Ensuring that the engine reaches and maintains the correct operating temperature is vital for optimal performance and fuel efficiency. Checking the sensor wire connections helps identify and rectify any issues such as loose or damaged connections that could lead to inaccurate temperature readings. The temperature gauge is responsible for displaying the engine's temperature to the driver. Ensuring the integrity of the wire connection before starting the engine helps prevent misreadings or malfunctionings of the gauge. Using a multimeter to check the power supply to the temperature sensor provides a quantitative measure of the electric current. This step helps identify any electrical issues that may be affecting the sensor's performance. Finally, observing the temperature meter while the engine is running provides real-time feedback on the coolant system's functionality. Any abnormal temperature readings or fluctuations may indicate underlying issues that need attention. The list provides a troubleshooting guide for various issues that may arise in the engine coolant system, along with corresponding actions to be addressed each problem. Let's explore each issue and recommended course of action. If the temperature meter or gauge is not functioning correctly, it can provide inaccurate readings, leading to a lack of awareness regarding the engine's temperature. Replacing the defective meter ensures accurate temperature monitoring. The temperature sensor is responsible for sending signals to the temperature gauge, and the defective sensor can result in incorrect temperature readings. Changing the sensor ensures that accurate data is transmitted to the gauge. Low coolant levels can lead to inadequate heat dissipation, causing the engine to overheat. Topping up the coolant ensures there is a sufficient amount to effectively regulate the engine temperature. Poor electrical connections can disrupt the communication between components, leading to inaccurate temperature readings. Replacing the faulty connection ensures a secure and reliable electrical flow. Using a multimeter, check the power supply to the temperature sensor provides a quantitative measure of the electrical current. This step helps identify any electrical issues that may be affecting the sensor performance. A malfunctioning thermostat can lead to improper coolant circulation, causing overheating. Replacing the thermostat ensures proper temperature control. Short circuits in the wiring can disrupt the electrical flow, leading to malfunctioning temperature readings. Repairing or replacing the wires resolves the short circuit. A defective engine control module (ECM) can result in incorrect temperature readings and other performance issues. Replacing the ECM addresses this problem. Inadequate power supply to the temperature sensor can lead to erratic readings. Checking and rectifying the power supply issue ensures a stable electrical connection for accurate sensor operation.
Let us recap this topic. In this topic, you have learned that low coolant levels can lead to inadequate heat dissipation, causing the engine to overheat. Topping up the coolant ensures there is a sufficient amount to effectively regulate the engine temperature. A malfunctioning thermostat can lead to improper coolant circulation, causing overheating. Replacing the thermostat ensures proper temperature control. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Namaskar and a very good morning. I am K.K. Mishra from Ministry of Power, Government of India, and I am here to discuss and talk about the various initiatives taken by Government of India, Ministry of Power regarding digital initiatives. This is a creation of an ecosystem which enables consumer not only to facilitate the various services but also empower and provide better and improved services over a long period of time. So